Doppler Radar. There wouldn't be meteorology today if it wasn't for the invention of Doppler Radar. Doppler Radar is one of the most important tools to a meteorologist and in the entire field of meteorology. So this month, Deep Dive is on Doppler Radar, which is amazing. So let's get right on into it. So you might be wondering, what is radar? And radar stands for radio detection and ranging. It is used to detect precipitation in thunderstorms. The National Weather Service uses it for examining storms with precision. On a severe thunderstorm or tornado warning, if you click into it, other than just the alert that you get on your phone, most likely you will see that those are prompted by radar indication. The ability to detect moving storms gives meteorologists a look into the storm to see if there's any rotation in the supercell or a tornado based on debris. This picture over here is the Lake Charles radar after Hurricane Laura struck the area with 130-mile-an-hour winds. Completely destroyed. So these aren't indestructible, and even though they are a lifeline, if one goes down, another radar has to pick it up, and at that point, it might not be as good as imagery because of where the closest radar is. So about Doppler radar. Doppler radar was invented in the 1940s, but the type the National Weather Service uses, the WSR-88D weather surveillance radar, was invented in 1988. Doppler radar can detect motions toward or away from the radar, and there are 155 WSR-88D radars in the nation, including Guam and Puerto Rico. These radars are operated by the National Weather Service and the Department of Defense. Here are the locations of all of them. NWS and DoD radar sites are indicated in blue, and Cuba's is operated by the FAA. How does radar work? Now, the Doppler radar uses the Doppler effect. So, 1. Radar waves are emitted from an antenna. The wave strikes an object in the atmosphere, causing the wave to scatter, and some of that wave comes back to the radar. The larger the object, the more energy that comes back. The amount of energy correlated to the size of precipitation and the time that it takes to get back to the radar correlates to the distance from the radar. Now, there are 3 types of radar imagery. There's reflectivity, relative motion, and precipitation. So, reflectivity paints a picture of the weather from the energy reflected back to the radar. Base reflectivity looks at one elevation, and composite reflectivity looks at multiple elevations. Doppler radar can detect relative motion toward or away from the radar. Base velocity is the wind speed in the storm system, including the storm's motion, and storm relative motion is the picture of the wind's circulation when the motion of the storm is subtracted from that equation. Radar can also detect precipitation. Radar can detect rainfall totals within an hour or within a whole storm, which in the whole storm it calculates all rainfall until there is no precipitation for 1 hour straight. It can show if singular storms are moving in different directions than the overall flow. That is all I have, just a quick deep dive into Doppler radar. It is kind of a minor part of meteorology when you think of it all. You think of the phenomena and all of that, but we can't observe those phenomena, especially in the US, without the Doppler radar. So even though it's just a big ball, and it looks like a big ball on the National Weather Service sites, it is very, very important and should not be overlooked. Thank you guys for watching, and I'll see you guys next time.